random experiment, and sample space, types of samples like discrete and continuous, natural explosive events, independent events, then probability space, then what is probability, algebra of events, then multiplication of addition to traditional probability we have seen, right? Till now, we have done these things. Let's continue with this. Okay.
Yes, sir.
Okay, now problems. Okay. Given that the two numbers appearing on throwing two dice are different, find the probability of the events, the sum of the numbers on the dice is 4. Yeah, this is conditional probability. Try to do this.
Sir, is it 1 by 15?
Yeah, any solutions?
Is it 1 by 15?
Uh, yes, correct. Good. I don't think I need to tell you the solution, right? I hope you have got the correct answer.
Yes, sir, I got it.
Yeah. So if you understand, right, it is easy to do. Like, just take the possibilities. Like, it is not the same number, right? So what and all is possible? 1, 3, 3, 1. Only two possibilities are there, right? And by the number of total possibilities is 36. So it is 1 by 15. Correct.
Yes.
Next problem, contrary to this, consider the experiment of throwing a die if a multiple of 3 comes up, throw the die again, and if any other number comes, toss a coin, find the conditional probability of event the coin shows a tail. Given that at least one die shows three. It is just complicated. Just try to solve this.
Sir, can you please explain the steps? Sir, hello?
Yeah, Ananya.
I don't think I can solve this completely.
Okay. I'll solve this. Okay. One second. So have you tried this? What are you thinking of?
Sorry, sir?
Have you tried it? What are you thinking about it?
No, sir. To get a multiple of 3, the probability will be 1 by 3, right? So there are two possibilities, 3 and 6.
Hmm.
So to tossing a coin, the probability will be 2 by 3, like to get any other number.
Okay, let's solve this. So consider an experiment of throwing a die. If a multiple of three comes up, throw the die again, and if any other number comes, toss a coin. Okay. Find the conditional probability event that the coin shows a tail, given that at least one die shows the tree. Means if three comes or multiple of three comes, I need to toss a coin. Sorry, I need to roll a dice. Other than that, if any other number comes, I need to toss a coin. That's the case here. Okay. So what is the sample space? So it is something like this. If one comes, I'll be tossing a coin. It will be either head or tail. If two comes, I'll be tossing the coin. It will be a head or tail. If three comes, I need to roll the dice. That is, either it can come one, or it can be two, it can be three, or it can be four, right? Okay. Or it can be five, or it can be a six. Then, if four comes, it is either head or tail because we'll be tossing a coin. Then, if five comes again, it is head or tails because we will be tossing a coin. But if six comes, I need to roll a dice. That is 6-1, 6-2, 6-3, then 6-4, 6-5, 6-6. This is the sample space. Have you understood this?
Yes, sir.
How many this one are there? Like how many possibilities are there? It is 20 possibilities are there. Just count it. Okay. So they are saying event one, a coin shows tail. What are the favoring events? The events which are favoring is 1T and 2T, 4T and 5T. The number of items in E is 4. And at least one die shows 3. That is the second thing. So the favoring events are 3-1, 3-2, even 3-3, because at least they are told 3-4, 3-5, 3-6, and one more will come, that is 6-3. Now that number of events here is for favoring is 7. So now I need to check what is the formula of this one, conditional probability E given that F, that is equal to P of E intersection F by P of F, right? Correct.
Yes.
Now P of E intersection F is equal to number of E intersection F, the number of items which are common, by the sample space. Number of events which are common in E and F are how much? It is 0. Correct. By 20 it is. There is no common things in between E and F. So hence the condition probability is also 0. There is no possibility. So whenever I get a 3 on the die, I will never get tail or head, because we'll be rolling the dice, not the coin, not the tossing the coin. That's why the probability is 0. Direct answer you can say, by if you understand the problem correctly, directly you can say it is 0, because whenever I'm getting the multiple of 3, I'll be rolling the dice, not the tossing of coin. So you will never get tail when you having multiple of 3 in the coin. Correct?
Yes, sir.
Yeah. That's it. Now let's next problem. Few more problems we'll do, then we'll come back to a topic. Okay. Yeah. An instructor has a question bank consisting of 300 easy true or false questions and 200 difficult true or false questions, and 500 easy MCQs, multiple choice questions. Okay, that's what there in the question bank. Now, if a question is selected at random from the question bank, what is the probability that it will be an easy question, given that it is a 1 second. Here I have missed one statement. So an instructor easy true or false, 200 difficult true or false, 500 MCQs. Okay, 500 easy MCQs, right? After that, there is one more statement here. 400 difficult MCQs. Okay, just add it. Now, if a question is selected at random from the question bank, what is the probability that it will be easy question, given that it is a MCQ? Try to solve this.
5/9.
Yeah, no, no, correct. It is. Okay. Next question. Okay. Next question. Last question for this. Okay. A black and a red dice are rolled. And the first question is find the conditional probability of obtaining a sum greater than 9 given that the black die resulted in a 5.
1/2.
Uh,
No, no.
check
Wait.
again.
2/6. 1/3.
Yeah, 1/3 it is. The last question, last sub question in this. Find the condition probability of obtaining a sum greater than 9. Sorry, find the condition probability of obtaining a sum of 8
2/3.
Let's check one second. No, check back.
Sir, can you spell this one?
Yeah, so just 1 second. I saw this. Okay. So let's go to the question. So conditional probability they are asking like obtaining a sum of 8, given that a red die is resulted in number less than 4, right? What and all probabilities are here? What so the sum should be 8, right? Let's find out sum should be 8. What and all possibilities are there? That is 1 7, 2 6 3 5 4 4, then 5 3 and 6 2. Correct. In this, what and all will not be correct. So given that red die resulted in a number less than 4, one of them I should take as red die. Okay, correct.
Sir, can we take 7 here because it's a die?
7 is not possible. Sorry. This is correct, right? 2 6 3 5 4 4 5 3 6 2. Correct. Now they are saying red die resulted in number less than 4, right? So the combination will be something like this. So if I take blue die, sorry, blue, no, black and red, black have possibilities of 1, 2, 3, 4, 5, 6. Red have only possibilities of 1, 2, 3, not even 4 because it is less than 4, right?
Yes, sir.
In this, what and all are favoring? If I so here almost you'll get 6 into 3, 18 combinations. In this, how many are common in between this and this set and this set?
4. No,
So
3.
anything you can take as so second, you can consider second die as the red here. Okay, only these two, right?
Yes, sir.
This is possible.
Mm, ye- yes. No. Are we considering red as the second die or
Sorry,
so here do we have to consider the red die as the second die or it can be something?
you are wish, but while considering one of so if you fix one as your red die, you should not be changing that. So here these two will be favoring. This is not possible, right? Because it is less than 4, it should be second one.
Yes.
And consider second die as the red die. Okay. So the common in between these two events is how much? 2. Total number of possibilities are how much?
18.
18. So it is 1 by 9.
Okay.
Okay. So yeah, let's continue with the discussion. What we did in the class condition probability we did, right? So okay, that's what the thing last we did. Now let's continue from that. Stop it. Okay, we'll take total probability. Okay. So, why we use total probability is when there are sample space, right? When the sample space is partitioned into several multiple mutually exclusive or exhaustive events, then we use total probability. I told in the last class, if you remember, I talked about mutually exclusive and exhaustive events, right? What is mutually exclusive event?
If there are no common
Yeah.
terms.
Between the events, if there is no common thing, they are called as mutually exclusive event. What is mutually exclusive and exhaustive? So if there are n events which are among them are mutually exclusive, and uh, the complete of them, if I minus with the sample space, it will result as a null set, right? Means they are like if the union of them, if I subtract from or if I do the set difference from this sample space, I'll get the null set. Such events are called as mutual exclusive and exhaustive events. Okay, so something like this, let's show through diagram. So if I have a sample space like a box structure like this is my complete sample space. So the events, what it is making is it is making the partition of the sample space. Okay, something like A1, A2, these are the events. A4, A5, A6, A7, A8. So so they are, if you can see in the diagram, they are mutually exclusive, right? Because there is no common thing in between them. Is there any common thing in between them?
No.
No, they are mutually exclusive. First of all, they should be mutually exclusive when they want to be mutually exhaustive. Okay, it is mutually exclusive. You can see it through diagram. So if I make the union of all the 8 events, and if I subtract from the sample space, the result will be null set. Okay,
Yes.
such events are will be taking care of you. Okay, so the definition here is, so the theorem of total probability is used when the sample space is partitioned into several mutually exclusive and exhaustive events. Let's see the conditions of it. Let B1, B2 till Bn. Okay, B a partition of the sample space is such that Bi any two events, the common thing between them is a null set, means it is mutually exclusive, right? For any I and j in sample space. So it means they are mutually exclusive. Correct? Correct, Ananya?
Yes.
Second one, if I make the same thing which I told, I'm now just now giving in the notes type of notes. If I make all the union of those sub events of sample space, will make the sample space. This is one way of saying, or you can say like the union, if I subtract from sample space or if I make the set difference, it is the null set again. So this is the condition for mutually exclusive exhaustive. Then and probability of any event which is sub event in the sample space will be greater than 0 for all I. This should be the third case. Then the total probability for any event A, then for any event A, belongs to that sample space, the probability of A will be equal to summation I is equal to 1 to n P of B into the condition probability of P of A given B I. Okay. See the problems, we'll understand better. Okay. Okay, take this question. A company has two plants. That is P1, plant P1 produces, plant means like the manufacturing event here, not the sapling plant. So plant P1 produces 60% of the items with a 1% defect rate, and plant P2 produces 40% of the items with a 2% defect rate. What is the probability that a randomly selected item is defective? Okay, this is the first question. So let's solve this. Let's consider D as the event that the item is defective. Okay. We have two plants, P1 and P2 are the event that the item is from either of plant P1 or P2. Now, so given, what is the given thing is, so if I choose any random item, what is the probability of it is being from plant 1? If I choose any item, what is the probability of that it is being from plant 1?
60%.
That is 0.6. Now, if I choose any item, which is, what is the probability of it is being from plant P2?
0.4.
0.4. Now, if it is from plant P1, what is the percentage of, what is the conditional probability that it being defective?
0.01.
Yes, it is 0.01%. What is the conditional probability of the defective item if it is from P2?
0.02.
Yeah. Then we should find out the total probability. So what is the total probability? If we have this, we should take. So this is the basic theorem. It should be adjusting it to our condition. So this is the basic theorem for our case. So what is the defective item they have asked, right? So what is the defective rate? So it is P of defective will be equal to the summation of it is from plant 1, given that it is defective and from plant 1, plus it is from plant 2, given that it is defective that from plant P2. The substituting and finding out. It is 0.6 into 0.01 plus 0.4 into 0.02. So it is equal to 0.014. This is the percentage, or it is the 1.4 percentage are there. Any item if I select, it will be defective. Yeah, like it is. So because of 1% from the plant P1, 2% from plant P2, overall 100%, we'll be having 1.4% of item will be defective. In 100%, I'm talking about. Have you understood this?
Yes, sir.
Have you written this?
Yes, yes.
Everything from here?
Yes, sir.
Okay, let me give a problem. Try to solve this. Two bags are there, and in bag one, we have three red and two green balls, and in bag two, we have one red and four green balls. A bag is chosen at random, and one ball is drawn. What is the probability that it is red?
Two by five.
1 second. Mm, no. 2 by 5, like, yeah, like 0.4%.
Yes.
Yeah, then it is correct. Okay. Any doubt in this problem?
No, sir.
Next problem I'll give. Try to solve this. This is one of the important conditional probability is easier than total probability. Total probability sometimes creates a confusion, so we should be clear with this. Okay. So let me get next problem. Okay. It is known that the population of a certain city consists of 45% female and 55% males. Suppose that 70% of the male are mm, riding bike and 10% of female ride bike. You can write like 10% of male, sorry, 70% of male and 10% of female ride the bike. Find the probability that in this first question is a person is a bike rider. If I choose a person randomly, what is the percentage of him being a rider without the gender consideration?
Forty-three percentage.
Yes. Next sub question. A biker is a male. Just cross question. Opposite. This is a conditional probability.
So can you solve this one?
So here it is something like a kind of a cross question. We know that he is a biker. Now they are asking what is the percentage of him being a male, right? So that is something like this. So we know that it is a biker, and we don't know what is the percentage of him being male. This is the condition probability. That is the percentage of male multiplied with total bikers who are male divided by the possibilities of being a biker. So you told it is 43% of any person being a biker, and the chances of being a male is 0.55%. And there are 70% of male who rides the bike, that is zero point 0.7. The answer will be 0.895. Mostly the biker, 89% of biker will be male in this case, in the biker kind of condition.
Got it.
Yeah. This is called as Bayes rule. Okay, let's talk about this. We have not talked much about this. So this is called as Bayes rule. Okay. The second question is based on Bayes rule. So let A1 till AN be a finite or countable portion of sample space with any of the event having probability higher than 0 for all I. Then for any event B belongs to that sample space with probability being greater than 0, the known thing of B and what is the chances of being it A, that is a conditional probability, is equal to P of AI and P of B given AI divided by P of B. This is the rule which we used. This is only applicable when you know the total probability value, then you can apply the total probability here. This is the total probability. Okay. Fine. Any doubts?
No, sir.
So we'll solve one last problem, right? Yeah. I hope my screen is visible.
Yes, sir.
One last problem, okay? It knows that there is a chance of 40% that the company he works with works will open a branch office in Bangalore. If that happens, the probability that he will be a manager, he will be the manager in that branch office is 80%. If not, the probability that he will one second. What is this? Hmm. Hmm. So the probability that he will be promoted as a manager to another office is 10%. Not itself. It is not the probability. Find the probability that Vivek will be appointed as a manager of a branch office. Yeah, try to do this or take it as a homework. Take it as a homework. Okay.
Okay,
Take a
sir.
screenshot or something and solve it and get me back to the next class. Okay.
Okay, sir. Okay.
Thank you, Ananya, for joining. We'll continue in the next class.
Thank you, sir.
Thank you.